Astronomers, how did your graphing go? After adding data for May 12th and May 14th, did your graph look like this? You'll see May 12th in purple and May 14th in pink. Very colourful. Is it similar to what you have? Great work. Now, did you come up with any ideas about why the length and direction of the shadow might be changing throughout the day? Did you guess it was something to do with the sun's position in the sky at different times? If so, well done. Excellent detective work. What do we know about the sun in the sky? Does it move throughout the day? No, it doesn't. The Earth is rotating on its axis, which makes it seem like the sun is moving across the sky, rising in the east and setting in the west, when really we're the ones moving. Good memory. Does this connect to what you observed about the direction of the shadows through the day? Excellent. The shadows moved from west to east throughout the day in the opposite direction to the positions of the sun. And it was the same every day, wasn't it? That's because if there's one thing we can always rely on, it's the sun rising in the east and setting in the west every day. The length of the shadow is also affected by the position of the sun in the sky. Let's use a model to visualize what's happening. This is the sun trajectory visual. A is the sun in the morning. B is where the sun is in the sky at midday, the middle of the day, which is sometimes known as noon. And C is where it is in the evening. Can you see how the shadows are labelled? Yes, they're labelled A, B, and C. Do you think that matches up with the A, B, and C positions of the sun in the sky? Yes, and they're pointing in the opposite direction to the sun that made them. For example, sun A is rising in the east and shadow A is pointing west. What else do you notice about the shadows? Excellent, yes. They're different lengths throughout the day. The shadow is longest in the morning, not long after sunrise, and shortest around noon, when the sun is highest in the sky. And just like our investigation, the shadow is longer again in the evening, but not as long as in the morning. Why do you think that is? Great answer. The length of the shadow depends on how close the sun is to the horizon, which is the point or line at which the Earth's surface and the sky appear to meet. Shadows are shorter when the sun is high in the sky and far away from the horizon than they are if the sun is lower and closer to the horizon. Does this help us understand what's happening in our shadow investigation in the Twig Science Lab? I wonder. Use your graph, the shadow direction data, and what we've discussed in this lesson to see if you can make a prediction in the Make Prediction section of your Twig book. What do you think will happen in our shadow investigation over the next few weeks? Then, to finish this lesson, I'd like you to put your new knowledge to the test by completing the Develop Model section in your Twig book. In Diagram 1, you need to draw where in the sky you think the sun is based on the length and direction of the shadow. In Diagram 2, you need to draw the shadow made by the stick based on the sun's position in the sky. Next time, we'll begin investigating another question. Why don't we fall off the Earth? Any ideas? Stick around and we'll see if you're right. Bye for now.